Hello everyone, welcome to our interactive session on operating system scheduling algorithms. Today our team Karthikeyan, Muthuram and myself Nishan Kannan will be explaining one of the most important CPU scheduling techniques used in operating systems. Let's get started by understanding round robin scheduling. Round robin scheduling is a fundamental concept in operating systems designed to manage how processors share CPU time. Imagine a circular queue where each process gets a fair turn at the CPU. This method is particularly effective in time-sharing environments, ensuring that no single process monopolizes the CPU. At the heart of the round-robin scheduling is the idea of the time quantum, a fixed time slice that each process can use before the CPU switches to the next one. Picture this. We have three processes. Let's call them P1, P2, and P3. Each process waits in a queue, ready to take its own turn.
When the CPU is free, it allocates time to P1 for a brief moment, then moves to P2 and finally to P3. This cycle continues, creating a rhythm that promotes fairness. Now let's dive deeper into how this works. When a process is allocated time quantum, it can execute for a duration, say 2 milliseconds. If it finishes its task within that time, it exits the queue. However, if it needs more time, it gets interrupted and sent back to the end of the queue. This ensures that every process gets a chance to run, preventing any single process from starving while others wait. One of the key benefits of round robin scheduling is its simplicity and fairness. Each process gets an equal opportunity to execute, which is crucial in multi-user and multitasking environments.
However, the efficiency of this algorithm heavily relies on the choice of time quantum. If the quantum is too short, the CPU may spend too much time switching between processes, leading to increased overhead. Conversely, if it's too long, the response time for processes may suffer, causing delays. Let's visualize this with a Gantt chart. Imagine P1 runs for 5 milliseconds, P2 for 4 milliseconds, and P3 for 2 milliseconds, all divided into 2 millisecond time slices. As each process takes its turn, we can see the context switching happening. This switching is essential for maintaining the flow of execution but can also contribute to waiting time, which is the time a process spends in the queue before getting its turn. In summary, round robin scheduling is a simple yet effective algorithm that ensures fairness in CPU scheduling. It allows multiple processes to share the CPU time equitably, making it a popular choice in many operating systems. However, the efficiency of this method depends on the careful selection of time quantum. Remember, while round robin promotes fairness, it's essential to balance the quantum to optimize performance. Thank you for exploring this crucial aspect of operating system with us.